Hi, and welcome back to the NUFYPET Maths Specimen 2021. In this video, I will be showing the solution to the problems 16 to 20 from the official math specimen for NUFYPET. Question number 16. What is the equation of the straight line passing through the point 4, 1, which is parallel to the line given by the equation 3x plus 2y equals 12? In this problem, we need to find the equation of a straight line that passes through the point 4, 1, and it is parallel to the line with the equation 3x plus 2y equals 12. So effectively, we have a slope of the line and the point through which that line passes, and we can form the equation of a straight line in the point-slope form. That will be y minus y1 equals m times x minus x1. X1, y1 are the coordinates of the point, the known point on the line, and m is the slope of the line. So let's find the slope of the line. From the given equation of the straight line, we just need to extract the slope m. So we would have 2y equals negative 3x plus whatever, and therefore y equals minus 3 over 2x plus whatever. I'm not interested to know what comes after the plus, I just need to extract this number over here. So m equals minus 3 over 2, and therefore the equation that we need to find will be y minus 1. Remember that 1 is the y coordinate, equals minus 3 over 2 times x minus 4. Let's now take a quick look at the form the answers are given in. Y is expressed in terms of x. We will do the same thing. So y equals minus 3 over 2x. Then we have plus 6 plus 1. So that's plus 7. And if we multiply now both sides by 2 to get rid of this 2 in the denominator, then we get 2y equals minus 3x plus 14. And let's check which answer that corresponds to. That's option C. Question number 17. For any real numbers, a, b, and c, where a is greater than or equal to b, consider the three statements. And we need to choose the correct statements. Which of the statements must be true? We have quite a few different options, so the best way is to actually look at the statements and think whether they are true or not. We are given three real numbers, a, b, and c. The first statement says that minus b is greater than or equal to minus a. What we've done here, we multiplied each side of the given inequality, a is greater than or equal to b, by negative 1. And when we do that, the sign of the inequality changes, so we can make the conclusion that the first statement is correct. Statement number 2, a squared plus b squared is greater than or equal to 2ab. We can immediately spot that this can be converted into a complete squared, so we can rewrite this as a minus b squared is greater than or equal to 0. Now, is this true? First of all, we know that the square of any number different from 0 is definitely positive. Now, if a is greater than b, then definitely a minus b squared will be greater than 0. And we need to also check when a equals b, then a minus b squared is equal to 0. Okay, that's satisfied as well. Therefore, we can make the conclusion that the statement is correct. Let's check the third statement. AC is greater than or equal to BC. This inequality would hold if C was positive or equal to 0, then in this case both the left and the right hand side of the inequality would have been 0. but we don't have enough information about C. So in case when C is negative, this inequality will not hold anymore. We don't know whether it's true, and in fact, it's not always true. It depends on the sign of the number C. Therefore, the only correct statements in this question are number 1 and 2. And the correct answer is B. Next question, 18. The question on stereometry. The cross-section of a triangular prism is an equilateral triangle with side 2x centimeters. The length of the prism is d centimeters. Let the total surface area of the prism be t centimeters squared. Given that the volume of the prism is t centimeters cubed, which one of the following is an expression for d in terms of x? When I looked at this problem before recording the video, I assumed the general case when the prism is not right, or we call it an oblique prism, like that. And of course that case wouldn't work because we don't have enough information about the height of the prism. It's not very clear to me what is meant by the length of the prism. The way I view the length is the length of the side, whereas in this question I think the authors meant the right prism, like this. And if this is the case, then it makes things easier because in this case the length of the prism corresponds to the height, which is d. So I think it's a wiser idea to stick to the right prism. So this prism is called an oblique prism. It's a general case, and this prism would be called the right prism because the sides of the prism are perpendicular to the bases, like this. We begin solving this problem by expressing the total surface area T in terms of the quantities that we have. The surface area of the prism consists of two triangles that make the bases of the prism, and we have three rectangular sides. So let's write it down as the area, two areas of triangles, plus three areas of the rectangle. The triangles in the base are equilateral. It means that all of the sides are equal to each other and they are 2x, and all of the angles are 60 degrees. So we can find the area of a single triangle by using the sine formula. That's half times 2x squared times sine of 60 degrees. That gives me half times 4x squared times root 3 over 2. So the 4 and the 2's will cancel out and we get x squared root 3. So we need two of these, and the area of each rectangle is found by multiplying the sides 2x and d. So the total surface area T is therefore equal to 2x squared root 3 plus 3 times 2xd, that's 6xd. The next step is to express the volume T, so the volume of the prism is equal to T, in terms of the quantities x and d. The volume of any prism equals to the area of the base times the height of the prism, in this case it's d. So the area of the base is the area of the triangle, and we have that, x squared root 3 times d. So let's put d at the front. dx squared root 3. And we know that this is equal to t. So now we have two equations that express t in terms of x. This is the first one, and this is the second equation. So we can therefore equate 2x squared root 3 plus 6xd to dx squared root 3. The task is to express d in terms of x. So I'm going to combine the like terms. The like terms are the ones that contain d. So if I take d as the common factor and in the brackets I have x squared root 3 minus 6x equals 2x squared root 3. Of course, we can divide both sides by x and express d in terms of x. So d equals 2x root 3 over x root 3 minus 6. And if we now look at possible answers, there's no 6 in the denominator, but there is 4 root 3 and there is 2 root 3. So what I need to do is to possibly divide both the numerator and the denominator by root 3. Let's try and do that. So that will give me 2x. I got rid of the root 3 in the numerator. And in the denominator then I would have x minus 2 root 3. Okay, so now that does look like one of the answers. Let's see, 2x over x minus 2 root 3. So this is the answer D. Question 19. A shape is formed by drawing a triangle ABC inside the triangle ADE. BC is parallel to DE. AB is 4 centimeters. BC is x centimeters. DE, the base of the bigger triangle, is x plus 3 centimeters, and DB equals x minus 4 centimeters. We need to calculate the length of the side DE. The answers are given in the numerical form, which means we need to solve some kind of equation for x and then substitute x to find the side DE. We can see in the sketch that the triangles ADE and the triangle ABC are similar. The sides AB and AD lie on the same line. Also, the sides AC and AE lie on the same line. And the side BC is parallel to the side DE. So we say that the triangles are similar. And therefore the ratio of the sides AB to BC in the triangle ABC will be the same as the ratio of the side AD to the side DE in the larger triangle ADE. AB is 4, BC is x, so 4 over x is equivalent to the ratio of AD. AD is 4 plus x minus 4, that's x, over DE x plus 3. Let's now use the rule of proportion. 4 times x plus 3, first diagonal, equals the second diagonal product of x and x squared. This gives us a quadratic equation, x squared minus 4x minus 12 equals 0. The Vieta formula tells us that the sum of the roots is 4, the product of the roots is minus 12. So the roots are x equals 6 and x equals minus 2. Clearly we must take a positive value of x, and it then follows that DE equals 6 plus 3, 9 centimeters. This corresponds to option C. Question 20. Let's zoom it in a little bit. A cube has unit length sides. What is the length of a line joining a vertex to the midpoint of one of the opposite faces, the dashed line on the diagram below? First of all, let's think about the terminology. A cube with unit length sides. It means that each side of the cube equals 1. Alright. Now I suggest we connect the point where the dashed line meets the bottom surface with the corner of the bottom surface like this. And let's say this is the triangle ABC. ABC is the right triangle. Therefore, we can use the Pythagoras formula that tells us that the square of the hypotenuse, in our case it's AC squared, equals the sum of the squares of two other sides. So AB squared plus BC squared. AB squared is equal to 1, and BC is half of the diagonal of the square. The diagonal of the square will be root 2, so BC will be root 2 over 2. Therefore, AC equals square root of 1 plus BC squared, that's 2 over 4 or a half. And this is square root of 3 over 2. This corresponds to option B.